Now, how does linear regression actually work? We want to fit a line to the data. And a line in 2 dimensions is always of the form y equals ax plus b, where y is the target, x is the single feature, and a and b are the parameters of the model that we want to learn. So the question of fitting is reduced to, how do we choose a and b? A common method is to define an error function for any given line, and then to choose the line that minimizes the error function. Such an error function is also called a loss or a cost function. Now, what will our loss function be? Intuitively, we want the line to be as close to the actual data points as possible. For this reason, we wish to minimize the vertical distance between the fit and the data. So for each data point, we calculate the vertical distance between it and the line. This distance is called a residual. Now, we could try to minimize the sum of the residuals, but then a large positive residual would cancel out a large negative residual. For this reason, we minimize the sum of the squares of the residuals. This will be our loss function, and using this loss function is commonly called ordinary least squares, or OLS for short. Note that this is the same as minimizing the mean squared error of the predictions on the training set. See our statistics curriculum for more detail. When you call fit on a linear regression model in scikit-learn, it performs this OLS under the hood. When we have 2 features and 1 target, a line is of the form y equals a1x1 plus a2x2 plus b. So to fit a linear regression model is to specify 3 variables, a1, a2, and b. In higher dimensions, that is when we have more than 1 or 2 features, a line is of this form, so fitting a linear regression model is to specify a coefficient ai for each feature, as well as the variable b. The scikit-learn API works exactly the same in this case. You pass the fit method 2 arrays, one containing the features, the other the target variable. Let's now see this in action. In this code, we are working with all the features from the Boston housing dataset. We split it into training and test sets. We instantiate the regressor, fit it on the training set, and predict on the test set. We saw that in the world of classification, we could use accuracy as a metric of model performance. The default scoring method for linear regression is called R². Intuitively, this metric quantifies the amount of variance in the target variable that is predicted from the feature variables. See the scikit-learn documentation and our statistics curriculum for more details. To compute the R², we once again apply the method score to the model and pass it 2 arguments, the test data and the test data target. Note that generally you will never use linear regression out of the box like this. You will most likely wish to use regularization, which we'll see soon, and which places further constraints on the model coefficients. However, learning about linear regression and how to use it in scikit-learn is an essential first step towards using regularized linear models.